Alright, going back now to our sample problem. So we are now solving for the k values, and we are using this table 1. As I've said, when it comes to the value of k, I would rather do interpolations, because here's my specific speed. Okay, so what's going to be the value of the k? So by interpolation, basically the mechanics for that, it's just you have to do this. Let's just write here k. There's our k value. So therefore, if I write, this is going to be 688 minus 610 all over 762 minus 610 is equal to k minus 79. Right, k minus 79 all over 97 minus 79. Okay, so one unknown, one equation. Then actually you can do that. You can shift solve, or you can just simplify. Okay, this will be 88.23 watts per mm. Okay, so check the result if it's somewhere in between. So here's 79 and here's 97, so I think we are on the right track, because this is somewhere in between. So now we can solve for the belt width, because we have this, we have the k, and we have this c theta. Therefore belt width is equal to what is our design power? This is 3,579.6, 3,700 579.6. This is in watts, and divided by the k, 88.23 watts per mm. Right, times the correction factor, which is 0.84. And this is 48.3 mm. Okay, so therefore use the belt width of 50 mm or 2 inches. Okay, so we have to check. Check table 3. Okay, so here's our table 3, and right here it says 51 mm. Okay, so that's just approximately 2 inches. Okay, so okay. Okay, so the next step is, we already have the width, we have the type, and we also have the number of ply. Then what's next is the belt length. Step number 6, solving for belt length. Okay, so we will use this equation. L is equal to 2c plus pi all over 2, since this is just an open drive, d plus d1 plus d sub 2, okay, plus d1 minus d sub 2, because this is open drive, is squared all over 4c. Okay, so let's substitute the values right here. 2 times 110, okay, plus pi all over 2 times this is 230, I think this is 230.6 or 230 plus 127 Okay, plus plus this difference of 230 minus 127 squared divided by 4 times 110. Okay, and what we get is 804. Okay, so right here is 804.8 mm. So approximately, let's just say 805 mm. Or if you need allowance, then you just have to include your allowance if you want. Okay, now for the pulley. Okay, so solving for the pulley width, because we already have the diameter, so the pulley width would be WP is just the width of the belt plus allowance. Okay, so from the table, our allowance is just less than 12 inches. Then we have a 1 inch allowance, or 25 mm. So therefore, the width of the belt is 50 plus 25. Then that's gonna be 75 mm. Okay, and finally, we just have to write the summary. So for the summary, for the belt selection, this is, we have a rubberized fabric, and we have a 50 mm by, that's the width by the 3-ply. Okay, and for the belt length of 805 mm. And for the pulley, we have D1 is equal to 127, okay, 127 mm, and the diameter of the driven pulley is 230 mm, and the width of the pulley must be 75 mm. Okay, so this is approximately 5 inches, and this is 9 inches, and here's approximately 3 inches. Okay, and we can also draw, if we want, illustrate the summary. Alright, so here's our pulley, and here's our belt. This is 50 mm. Right here is 75 mm, and the diameter that can be D1 or D sub 2. Okay, this is 3-ply rubberized fabric. Okay, so I guess that's enough for this topic on flat belt drives. Before I end this, I just would like to emphasize that in practice, if we have the manufacturer's catalogs, then it's always recommended that you use the manufacturer's catalogs. Although we have these standards, or there are other codes, it's really intuitive to actually base the computations from their procedures. And although there would be differences in the procedure, but I guess the idea or the mechanics and how you solve, or how do you select the belt drives, is through charts and through tables and through some equations. So if I were to choose, then if ever there's an available manufacturer's catalog, then I would go for that. And as well, I will also have to do this just to check out and to compare the results. Okay, so I guess that's all for now, and see you in the next in our next topic, which is the selection for roller chain drives. Right, see you.